Buoyancy. Buoyancy talks of the solids floating in liquids. Basically, it tries to explain what is the force, buoyancy force of liquid on the solid, which is immersed in it or floating in it. So let us take, for example, we know that the wood floats. Why does wood float? Because it has a lesser density. Whereas metal, if you put it in water, what happens to metal? It sinks because it has greater density. So wood floats because of its smaller density. Metal sinks because of its greater density. So when this metal, let's say a metallic body, is submerged in water, what is observed is that the apparent weight has diminished. See, when you remove it, again the weight will be the same. It is not that the metal gets melted and the weight is gone. No, weight is not lost. But it appears that when a heavier body, which is sinking into the liquid, say for example water, then the weight appears to have diminished. Let's see, for example, an experiment can be conducted on this, wherein there is a weight scale and hang to it a box of wood with the dimensions length A and breadth B and height C. Now this is hanging in the air. Now the same box we will immerse into the tank of water. Let's say there is a liquid in it and the box is hung here. And the box is basically submerged. This is A, this is B, and this is C. And the water level is here. Now from the water level surface to the surface of the box, let us call it as H. So, in this case, what happens? From the water level to the bottom of the surface, this becomes H plus C. Because this is nothing but the height of the box C, and from top surface of the box to water surface is H. So, it becomes H plus C. Having known all this, this is in air, this figure is in liquid. Now let us see what happens basically. The liquid in this figure exerts an upward buoyant force, an upward thrust. Buoyancy is nothing but a thrust. So it exerts an upward buoyant force on the box, so that the string that is hanging the scale will show an apparently lesser weight than what it is in the air. So basically, we will see that the string shows a lesser weight. So it shows a lesser weight than the actual weight. Why does it happen? The scale reading we can see in this experiment. This is larger figure and this is lesser figure. So from this observations, from this experiment, we understand that when a body is submerged in the liquid, its apparent weight seems to be diminished compared to its actual weight. Let us understand it and derive the buoyant force from this example. So what is happening here? At the bottom of the box, when it is submerged, there is an upward buoyant force. And on top of the box, there is a downward buoyant force. Now, buoyancy is defined as the difference between this upward buoyant force and downward buoyant force. Now, how do we calculate this upward and downward forces and then understand the definition for buoyancy. For this, we need one more parameter, which is the density of the liquid. Let us say D is density of the liquid. Now, with all these parameters in the figure in mind, let us understand what is the downward pressure. The downward pressure that is acting on the box. From these pressures, we can find the buoyant force. How is the pressure defined? Pressure is defined as the density of the liquid and the distance on which it is acting on. So, if you are seeing downward pressure, the downward pressure acting on it is from the top of the liquid to the top surface of the box, which is H. So, it becomes D into H. In the same manner, what is the upward pressure? See, the upward pressure is on the entire height because it is acting from the bottom on the whole box up to the top level of the liquid. So, this becomes density into H plus C. Having known pressure, we know how to calculate force because downward force is pressure downward into the area on which it is acting on. Because pressure into area is force. So, if you take D into H as P down and D into H plus C as P up, that is pressure down and pressure up, we get this one as P down is D into H into area. The area on which it acts is AB because it's a rectangle, length is A and this is B. So, it becomes DHAB. In the same manner, similar manner, let us find the upward force. Upward force is pressure upward into area. So, pressure upward is D into H plus C into area is again AB because whether it is upward or downward, the surface area is the same. So, this becomes DHAB plus DABC. Now, the buoyancy is defined as the difference in these two pressures. So, the buoyancy is F up minus F down because it is sinking. F up is higher since it is acting on a higher length. So, F up is DHAB plus DABC minus F down is DHAB. Now, DHAB gets cancelled and we get D into ABC. Now, here D is density of liquid. You can say liquid or fluid, and ABC is volume of liquid displaced. Buoyancy is defined as the weight of liquid displaced because density into volume is nothing but weight. So, weight of liquid displaced is buoyancy. So, we know that the density into volume is weight because density is defined as weight by volume. So, weight becomes density into volume. So, weight of the liquid displaced by submerging is equal to density of liquid into volume of liquid displaced, which is nothing but buoyancy.